Yes, so good evening everyone and welcome once again after a long time. Before starting the today's topic, I would like to I would like all of you to have a look at this that today our topic is nuclear and particle physics instead of quantum mechanics. Okay, already quantum mechanics was going on, but today's topic is different. The reason is very simple and I am really sorry for being not available for past 3 months. And the reason is very obvious that there must have been some family issue, so that's why I was not available. But whatever may be the case, today's topic is nuclear and particle physics, and we are starting this new topic. But before that, just have a look at the FAQs, which many students keep asking. Okay, so many students ask these FAQs. So these are the FAQs. What about physics optional paper number one? Okay, so the answer is there that I cannot promise, but must be over before August. Okay, and what about paper two of the same? So that also I cannot promise, but must be over before July. Okay, these are the two things which are there. I have stopped making promises because I was not able to fulfill the previous promise. The previous promise said that it must be over by January, right? The physics optional promise was that it must be over by January 15. But some unfortunate incidences, I was not able to do so. So now the plan is very simple that I will upload about two lectures every day. I am going to upload, okay, about two lectures every day, and most probably these two lectures will be of 2 hours each. Okay, I will try to keep them 2 hours long. Okay, so you will have to and in these 2 hours everything will be covered. Okay, so let's start our today's topic, which is nuclear and particle physics. But before studying this topic, let me mark over here that this part is for video, so I will not write anything over here. Okay, so what about nuclear and particle physics? So this is a important topic of physics optional paper 2 in UPSC, and every year questions are asked based on this. Okay, so what is the weightage and all those things? Those you can search anywhere, you will get them. Only thing is you will not get the teaching of free of cost which you will get here. The analysis and everything else you will get on every other channel. Okay, so let's come over here. You were learning what you were learning till the 12th standard. Up to the 12th standard, you used to learn what? You used to learn about the electrons. The focus was on electrons. This was the nucleus, and up to the 12th standard, the Rutherford model was very favorite one. That there is a nucleus and the electrons are revolving. Okay, what it used to say, that electrons are revolving around this nucleus. Okay, so this was the Rutherford planetary model of atom, which was later on rejected by Niels Bohr. Okay, not rejected, actually Niels Bohr accepted that these electrons are revolving, but Niels Bohr further added that these energy levels are quantized. Okay, but the scientists which came after those de Broglie hypothesis and all those things, which when they came over there, so they simply taught you that in a reality there is a quantum mechanics is the real thing for electron. Okay, and if you must have seen the previous lectures of quantum mechanics which I have already uploaded over here, then about in those previous lectures of quantum mechanics, you must have seen that I had already taught you that electrons do not revolve actually. I had taught you, right, that electrons do not revolve. Actually, the thing is that electrons are in the shape of orbitals. Like this is the p orbital, so the electron cloud will look in the shape of a p orbital. If this is the nucleus, suppose, then if the electron is in 2p orbital, then the electron cloud of the 2p orbital will look like this. If the electron is in 3d, okay, so if it is in 3d, then like this, these are the orbital shapes which I had already told you, right? And many more are there. I had told you this is a part of chemistry, okay? 2p, 3d, and 2s, 1s, all those things, which was the focus till 12th standard. All these things were your focus till the 12th standard, right? Now, what about when you went to engineering? When you went to engineering, the focus from all these things went off, okay? All these things were not at all important after engineering. So you what you learnt in the engineering, just a second, lot of disturbances over here, okay? So the disturbance is gone now. Let's look at this. So what I was telling you that up to the 12th standard your focus was much of on these electrons which are there in the outer shell. But what happened from engineering or the BSc, when you started to learn, the focus shifted from those things. All these things were a part of chemistry, that 1s orbital, 2s, 2p, 3d, and all these things. But from engineering onwards, or from after that, or in MSc, if you must have done MSc in physics, then you must have learnt all those things, that this is the nucleus and these are the electrons. So the focus of these electrons is gone now, and in the higher classes you are studying about nucleus. So the atom comprises of two parts. First of all, this is nucleus. Then there will be 1s orbital. Then there will be 2s orbital. So how the atom looks like, I am telling you. Okay. Then there will be 2p orbital. Okay. All these things are present at the same time in the atom. Okay. Then you have 3s. Then there will be 3s like this. Okay. So overall your atom will look spherical type. Then you will have 3p, right? Then you will have 3p. Then you will have 3d after that. Okay. So all these things when you combine, so it will be a complex electron cloud. Your atom, what will be your atom? Your atom will be a complex electron cloud. But in the lower classes, or say in chemistry also, in the chemistry and lower classes, your focus is on the outer electron cloud. Okay. But when you come to the nucleus, the things are very different. This nucleus was studied far later, far after the electrons. Okay, so this was studied, nucleus was studied. So first of all, right over here, for a long time, nucleus was not, nucleus could not be right like this. Okay, for a long time, nucleus could not be studied because of its extremely small size. So for a long time, nucleus could not be studied because its size is extremely small, and only the atom could be studied. So the atom is of the size of what? Your atom is 10 to the power minus 10 meter. Okay. What does this mean? So if suppose this is the nucleus and this is the outermost shell, means outermost part where the electron is found. This is the outermost part, and all these are inner electrons, and over here the last electron is found in this shell, suppose. Okay, So your atom ranges from here till here, your atom's radius, okay, from here till here means the from the center of the nucleus till the outermost shell where the last electron is there. So this radius will be 10 to the power minus 10 meter. Now how can you imagine this 10 to the power minus 10 meter? In order to imagine this, first of all you convert this into centimeter. So as soon as you convert this into centimeter, what will you get? 10 to the power minus 8 centimeter you will get. Okay. Then take a 15 centimeter scale. Okay. Take a 15 centimeter scale which you have it at your home. Take its 1 centimeter. Okay. Take its 1 centimeter. And for that 1 centimeter, cut this 1 centimeter. The size of atom, I am just making you imagine the size of atom. Okay. So you take 15 centimeter scale and take out 1 centimeter from it like this, okay, and from that 1 centimeter you cut that 1 centimeter into how many parts? In order to get 10 to the power minus 8 centimeter, you cut this 1 centimeter into 10 to the power 8 parts, okay. Now what does it mean by 10 to the power 8 parts? 10 to the power 8 parts means after 1 you will put 8 zeros. 1, 2, 3, 4, 5, 6, 7, 8. So these many parts you must do. You must partition this 1 centimeter corner of your 15 centimeter scale. This part 1 centimeter part of your 15 centimeter scale you must cut it into 10 to the power 8 parts, and 10 to the power 8 means 8 zeros after 1, okay. So if you cut it into those many parts you will go on the atomic scale, okay. So that is what is meant by the size of the atom is 10 to the power minus 8 centimeter or 10 to the power 10 meter, minus 10 meter, okay. This is what is the meaning of your atom, okay. Atom size 10 to the power minus 10 meter or 10 to the power minus 8 centimeter. Now what about nucleus? Okay, what about nucleus? Nucleus means it is 10 to the power minus 15 meter. About its size is about roughly 10 to the power minus 15 meter. Now how to imagine this? Okay, about atom I had already told you. About atom I had told you that it is 10 to the power minus 10 meter, right? So what about nucleus? Then for nucleus, you convert this as the, for example, you had converted this into centimeter, right? So you will convert this also into centimeter. So as soon as you convert it into centimeter, it will look something like this. Okay, and for atom, for example, you took the 1 centimeter box out of your this 1 centimeter part of 15 centimeter scale. Okay, which you have at your home. Okay, now for atom I had done how many parts? 10 to the power 8 parts I had done. Okay, this area was divided into 10 to the power 8 parts for atom. Now for nucleus you will have to divide it into how many parts? 10 to the power plus 13 parts. For example, here I had divided into 10 to the power plus 8 parts. For nucleus you will have to divide into 10 to the power plus 13 parts. This much only. Okay, so what is 10 to the power 13 parts? This much parts you must do. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and this 13. These many parts if you do of a 1 centimeter part of your 15 centimeter scale, if you divide the 1 centimeter into these many parts, okay, these many parts means 10 to the power 13 parts, then actually you will get the nuclear size, okay. For atom it was 10 to the power 8 parts, and for nucleus it is 10 to the power 13 parts. So your atom is how many times big than your nucleus? Your atom is equal to, for example, atom is 10 to the power minus 10 meter, and your nucleus is 10 to the power minus 15 meter. So how many times atom is bigger than nucleus? So you will simply divide this, right? How many times atom is bigger than the nucleus? So you will put this in the numerator and divided by 10 to the power minus 15, because in 10 to the power minus 10, how many 10 to the power minus 15 may come, you will find out that. So you will get that how many nucleus means what is the size of a nucleus in front of an atom. You will get that this is an atom, okay, this is an atom and this is a nucleus point sized. So what is the size of the atom in front of the nucleus if you want to find out? For example, if you want to find out how much bigger is 4 as compared to 2, how much bigger is 4 as compared to 2, if you have to find out, then what do? You simply make it 4 by 2, okay. So that is the thing. So it comes out to be 2. So 4 is 2 times greater than 2. Similarly, if I ask you how many times is 6 greater than 3, so 6 divided by 3 means 6 is 2 times greater than 3. Yes. So how many times is atom bigger than the nucleus? So 10 to the power minus 10 divided by 10 to the power minus 15. That means 10 to the power 5 times bigger. Atom is 10 to the power 5 times bigger than the nucleus. Okay. Then how did this come? This came from the laws of indices which you have learnt in the lower classes. Okay, this minus 15 will go up and it will become plus 15. Okay, you know na, a to the power m divided by a to the power n. What is it? Laws of indices you must have learnt in the lower classes. A to the power m minus n it is, right? So put m is a is equal to 10, a is equal to 10, m is equal to minus 10, and n is equal to minus 15 over there. So you will simply get this, okay. So the atom is 10 to the power 5 times bigger than the nucleus. What does this mean? This means that the nucleus is like this, then the atom cannot even be drawn on this screen, okay. Atom will be out of the screen, okay. So you can imagine the nucleus like it is your cricket stadium, suppose, okay. Suppose this is your cricket stadium. Suppose this is your cricket stadium, okay. So cricket stadium is very huge, right? International cricket stadium, assume it to be international cricket stadium. So the cricket ball which is at the if it is kept at the center, if the cricket ball is kept at the center of the pitch, okay, the cricket pitch is over here, right? So if you keep a ball, cork ball or a cricket ball over there, then this ball will be the nucleus, okay. Then this ball will be the nucleus of the atom. This ball is going to be the nucleus of the atom, and your this entire stadium is what? This entire stadium is your atom. So much is the difference between atom and the nucleus. And from where this is evident? This is evident from the fact that atom is 10 to the power 5 times nucleus, okay, bigger than nucleus, 10 to the power 5 times bigger than nucleus, okay. This we have already proved over here, right? So that's how the nucleus, that's the size of a nucleus. And up to the 12th standard, what you learn? Up to the 12th standard you learn all these things, okay. Up to the 12th standard you learn the outer things, okay. But in the graduation and post graduation level you start learning this, okay. Now you are going to learn this, and this is what this chapter is meant for. This chapter it is meant for this thing, okay. This red one, this yellow one you have already learned up to your 12th. Now the turn is for this red one, okay. So let me stop the recording over here, and I will continue after some time. Just wait for a second, okay. So अभी इतना ही रखते दोस्तों. Right now we will keep up to here only, okay. So have a look at this, okay. Whatever I have written over here, we will end the class here. See you in the next class. Okay, I will complete quantum mechanics in the end of the syllabus, okay. Towards the end, in the month of August or September, we will do quantum mechanics, okay. Not September but August. In the month of August, we will do the remaining quantum mechanics, but right now it is nuclear and particle physics which we will cover. Okay, so thank you very much. Jai Hind, Jai Bharat.